Hi, welcome to our notes for page 42 to 44 today. Let's zoom in here and get going. So our goal today is I can determine if if an equation, graph, or table represents a function. I can determine if an equation, graph, or table represents a function. So it says drag each definition to match the correct word. The y values, the outputs, that's the range. And then the x values, that's the domain. And so as you are going through here, anytime it lists x values, it's talking about the domain. Anytime it lists y values, it's talking about the range. Now, I remember this because x comes before y and d comes before r. And so even as an adult who's taught middle school math so many years, that's how I remember which one's the domain and which one's the range. Domain comes before, d comes before r, x comes before y. So domain is x, range is y. A set of ordered pairs is going to be a relation. And so normally, like pretty much everything that we were talking about in equations and graphs and tables, all of those are relations, but only a certain amount of those are functions. And it is a rule that assigns exactly one input to exactly one output, meaning the x's cannot repeat. So it says determine if the relation 3, 5, 2, 1, 1, 4, and 5, 5 is a function by making a mapping and a graph. So 3, 5, basically what you want to do is you want to point to the 3 and then you're going to rotate this x down. That is not how you rotate that x. Let's see here. See if I can click it right here. Rotate that down to the 5. So 3, 5, the domain, the x points to the y, the range. So for 2, 1, we'd have that here, and then we'll shrink it and rotate it to point it to the 1. And again, what I'm doing after I click and drag is you'll see this little circle here. You want to click that, and then that'll rotate and change the size so you can point it to what you want it to. And then 5, 5. So when you look here, you will notice that every x goes to a y. And so therefore, none of the x repeat. This one would be a function. Let's look about or how this looks on a graph. So 3, 5, 2, 1, 1, 4, and then 5, 5. So it's definitely not a straight line. So it's not a linear function. But since none of the x's repeat, it would be considered a function. So is it a function? Yes. No x's repeat. Let's see if I can spell that right. Repeat. Okay, moving on to the next page here. Determine if this relation is a function. So we're going to do our little mapping thing again. So we're going to take 1, that's the x, match it to the y, that's a 1. This one says 2, 3. Then you have 3. I was like, I did not hit the right thing. Yay for the undo button. So 3, take that down to 4. 4 goes to 5, and then we have 3, 0. So 3, bring this one down to 0. Okay, so this one you can tell is not a function because when you look here, 3 goes to 2 different numbers. Since the x doesn't repeat, since the x repeats, it is not a function. Let's look at what it looks like on a graph. So we have 1, 1. My circles are about as big as my graph. 2, 3, 3, 4, 4, 5, and then 3, 0. So you'll see right here that since these two are like on the same vertical line, it is not a function. X's repeat. Okay, stay tuned to video 2 to finish these.